Hey everyone, I hope you all are enjoying the whole Eagles Festival day off type thing. But regardless, we still need to do a little bit of JavaScript lecture so you aren't all clueless on this next homework. So with that, let's just get started. I don't think that there are any sort of like logistical sort of things that we need to cover. Homework 4 is still due this Sunday, and then homework 5 will be out hopefully by tomorrow evening, if not Friday morning, and will be due the following Sunday as usual. With regards to just like a sort of outlook on the rest of the semester, so after this homework, homework 4, after that's done, we'll have homework 5, which is going to be for WebSockets, homework 6, which is going to be servers and Express.js. Homework 7 is going to be React Redux. Homework 8, we're going to take like a little bit of a break and just do Chrome extensions. And then homework 9 is going to be a full stack React application that we're working on pulling together with final touches and testing and stuff like that. But Twitter for Birds, it's a real thing. So with that, let's just jump right into the lecture. So today we're going to be talking about this concept of a real-time web application. But before we can talk about that, we first need to just go over exactly what is the concept of a server and how most web applications just end up doing HTTP requests and things like that. So whenever we think about a website or a web server or anything like that in general, we typically have this sort of intuitive idea of what happens. So let's say that I access some site like Google. What happens is I, as a client, that's me accessing Google from my own computer, will go put in my search bar google.com. Once I click enter, a request will be made to Google servers. Google servers is going to do some processing on that request and then send me back an index.html page or whatever page is actually relevant to what I need. So you can see that this is sort of like a single transaction and then we're sort of done. So once I make a request, Google does its job and it fulfills that request, and then it has nothing else to do with me until I make another request, and so on and so on. So everything has to be client initiated for anything to be done. Additionally, there's no real concept of keeping a connection live with the server. Everything is just sort of like do one thing, that's it. If you want to do something else, you'll need to do like that whole cycle over and over again. So this is good if your entire web service just revolves around, just spitting out like a single page and then you're done, or, submitting like form requests and things like that. However, if you're dealing with perhaps a live web chat application, that's when things can get a little bit tricky. So like let's say that you're facebook.com and you want to implement Messenger. So the traditional way of you doing it, if you were to just limit yourself to the idea that I was talking about earlier, is that anytime you would actually need to fetch new messages from the server, you would need to get, that's the HTTP verb, it's called get, but you would need to initiate a request, check the server will then do some processing based on, whatever user ID you feed it and whatever chat you're currently in. And then it will send you back like this whole new string of like, what are the new messages and things like that. But that isn't really real time. That's more of just you as a client just saying that like, oh, every second I'll be checking the server for any sort of new messages as they come across. But there is no persistent connection. It isn't like the server is going to be immediately notifying you whenever a new message comes across. It's upon you as the client to take upon the onus to just go ahead and keep on checking for messages, iteratively or on an interval. So WebSockets are the way to have a connection that actually persists between a client and a server. And not only just a single client and a server, it could be multiple clients on the server, sometimes in the order of millions of clients and some order of servers. So that's the way that we manage to get collaborative applications like Google Docs. So you as a client need to be aware of changes that are happening in real time, because if you're relying on this like sort of 1 second delay that you keep on checking and checking, well, you're gonna end up like being in this situation where like two of you are writing on the exact same line, and then like you'll have to like merge these two different changes together, and that presents like its own sort of like complicated situation in and of itself. With sockets, you can just be assured that whenever someone else makes a change to, let's say that you're looking at a document, then you will also see those changes in relatively real time. Additionally, any changes that you make can be broadcasted to anyone else who's connected on the same socket as you are. You can sort of envision this as like a tunnel of sorts, or just like some sort of like hub that has multiple connected nodes to it. Whenever one node, I should say, rather, sends a message to this hub, it can be broadcast to every single other person on this hub, or it can actually be directed towards a specific person as well. Additionally, your center hub, that is the server, has the ability to send out messages to individual people, or it can send out messages to everyone else. And the great beauty of this is that you as a client no longer need to initiate requests in order for the server to respond to you. The server, once it's connected to you via a WebSocket, can just go ahead and start sending out information to clients unprompted. You may think that this is like a little bit scary, but it's essential to how chat applications work. You're not checking every second to see whether there's a new message on the server. The server is just sending that message to you from the get-go. So this is just sort of a way of visualizing the difference between WebSockets and HTTP stuff. So whenever whenever you have like a traditional HTTP request, it would be something very similar to this, where a client can send a request to the server and the server sends something back. But this image, I should say, actually represents like how an initial WebSocket connection is actually set up. So yes, although there is like this initial HTTP-like connection, that's sort of like a request and response back, that's what's used to set up like this sort of agreement between the client and server that there is an actual socket connection happening. Once a socket connection is opened, then you have the opportunity to send bidirectional messages, meaning that client can send a message to the server and server can send a message to the client. And then additionally, you have this final thing that happens whenever one of the clients or one of the servers just closes off the connection, which would be the equivalent of you like closing off your web page or something like that. So whenever we talk about servers and things like that, usually, well, I shouldn't say usually, but like they have to be coded in something, but they can be coded up in a variety of languages. I mean, prior to like the mid-2000s, everything was pretty much in like PHP or Python or some other variant of that language. However, it wasn't until Ryan Dahl, who's the creator of Node.js, came up with the Node.js framework that you're able to actually use JavaScript to program on the server in addition to the client. And that's what really drew developers to start developing in JavaScript, and what has made it such a huge ecosystem today. Because not only are there people developing client-side applications, there are also people developing server-side applications. And one of those applications is something called Socket.io, which has both the server-side implementation and a client-side implementation. So the server-side implementation handles like the actual logistics of creating those WebSockets, because there is an RFC spec that they need to implement. And then the client-side version of that library handles what to do and how to connect to that WebSocket and handle messages that are sent between the client and the server. So Socket.io itself is this sort of library that is on both sides of this whole exchange, as I mentioned before. So it enables bidirectional communication, and not only is it used for WebSockets, it also has fallbacks just in case WebSockets aren't available. So if you've heard of AJAX requests, which are asynchronous requests that happen in the background of your web page, Socket.io will default to that if your WebSockets don't work. And there are a bunch of other different things that Socket.io does behind the scenes that you don't really need to worry about. Just know that it's probably like one of the best solutions out there if you want this sort of integrated socket or WebSocket sort of implementation for yourself. Okay, and now we're just going to go into the code demo. So eventually what we're going to be building is a real-time chat application, and you can see what I mean here. So pulling up localhost 3000, it says pick a username. I'm going to say Abhi. Okay, I can type a message in. Hi, my name is Abhi. Press enter and it will appear. Now let me become a new client. It'll ask me for a new username. Let me type in Abhi again just to try to fool the system. It says, sorry, the username is taken. All right, let me say Suri. It says, hi, I'm Suri. You'll see here that on the left-hand side, you'll see Suri has now appeared, and then on the right-hand side, you only see Suri here. On the left-hand side, let me just like add a new message like, hey there. And now you'll see that there's a new message on both sides of this application as well. Let me just open up a third window or refresh this one. Let me pick up a new name that I haven't done before. Let's say like localhost. What's up, y'all? So you'll see that now localhost messages now broadcast to everyone else. And you can continue typing in messages and everyone else can continue typing as well. Unfortunately, I'm only one person, so I can't really exhibit the idea of typing simultaneous messages. But yeah, you get the gist. It's like anyone can connect to this website and they'll be able to send messages that everyone else will be able to receive. Pretty cool. Note that if you type in localhost 3000 on your computer right now, you're not going to be getting the exact same thing. As localhost would imply, this is just running locally on my computer. If I have time, or maybe afterwards, after I'm done recording this lecture, I can go through how you'd use a service something like Heroku to actually make this something that you and your friends could potentially use. Okay. Oh, yes. I should also note that if I were to restart the server and then refresh, or let me just like completely refresh the page, there is no concept of memory or anything like that. I can keep on picking up the same usernames and stuff like that. So yeah, that means that this web application isn't actually connected to any sort of database. That's something that we may cover later on, and you're going to be getting familiar with, at least for the last homework. Anyway, let's just get started. So what I'm going to do is that I'm going to go into my testing folder, into lecture examples. No, not that. There we go. And let me make this a little bit bigger. Yeah. Okay, so lecture examples folder. I'm going to make a new directory, socket lecture example. Sorry, you may be hearing a lot of clicky. I'm not sure. I'm just using QuickTime to record everything. But yeah. Since we're starting off a new JavaScript project, we're going to use npm init to initialize an npm package.json file. You may have been seeing this in your homework directory so far. What package.json does is that it actually just specifies all the dependencies that your project will have. In order for you to share, or I'm not sorry, share, but like in order for you to save your dependencies in a single location without actually uploading your dependencies with every single git commit or anything like that, you can just use the package.json file. Anyway, so I'm going to be sticking with this name. Yeah, version 1.0, don't need to put a description. Yeah, you can just keep on pressing enter and this will just all be auto-generated. So now if I do ls, you'll see that there is a package.json file here. If I just print out whatever is there, you'll just see it's basically all the information that they were prompting me for. Okay, so now what I'm going to do is that I'm just going to create a basic HTML server, and let me just get set up here with my environment. Okay, So in here, I'm going to create a file called server.js, and I'm going to import HTTP, which is Node's HTTP library that just comes baked in. Additionally, I guess I'll start off with that. So right now, I'm just going to create a really basic server with http.createServer. This accepts a callback function that has two arguments, rec and res. So a note on these two things. So rec represents the request object and res represents the response object. Note that the request object contains methods like, getting whatever the current URL is that the client actually requested the site with. Res contains things like sending back a response to the user and things like that. These two variable names are once again not something that's actually enforced. They just need to be two arguments. I could name it A and B, but common practice would just say name it rec and res or request and response if you want to. But everywhere you'll see this like rec and res. Anyway, so let's just start off by writing out a simple HTTP response. So I'm going to say res.writeHead 200 content type is, let's see, I need to put it there, text/HTML. All right, and then we're just going to say res.write h1 hello world and res.end. Lastly, at the end of this create server call, I'm going to call listen 3000. Okay. So what this is doing is that I'm creating an HTTP server that's accepting this callback. We're going to use the res argument that's passed into this callback that indicates the response object and associated methods. Using the writeHead method, I'm going to say I'm going to write back a 200 response to the person who accesses the site. 200 response, as you may remember from, homework 2, I think, indicates that everything's all right. This additional object here says that the content that's going to be coming to the page is an HTML string. I'm going to write to this response this HTML string, which is just the header1 tag containing the text hello world. And lastly, I'm going to end the response. Additionally, I'm going to say, let's open up port 3000 of our server for a person to just come in and listen on, i.e. be able to access the server itself. So whenever I'm running this locally, this means that it's automatically going to be listening to, it's going to be opening up port 3000 on localhost. Localhost is just a way, it's just like a local server that you have running on your computer once you actually start this up. Okay, so now let me just confirm that I'm in the right directory. I can run node server.js. Oh, let's see what I have here. Oh, sorry, I have currently running server on that port. Yeah, if you see this error EAddr in use, that means the address is in use. You may see this come up very often. Just be sure that there aren't any other running servers that expose the same port. Anyway, let's try this again. Okay, that seems to be okay. Nothing's yelling at me. So anyway, let me just close out these extra windows here. All right, so if I visit localhost 3000 now, it's just going to say hello world. Additionally, if I just say like hi Obby on top of that, now if I just refresh the page, nothing's going to happen, and that's because Node itself doesn't automatically listen for changes. You need to restart it every single time you want to do that. However, I have this tool called nodemon, which you can get by doing, I believe, npm install-g nodemon. And what nodemon does is that it just listens for changes on the file that you pass in as its first argument. So we're just going to be listening to changes on server.js. Okay. So refresh here, everything's working fine. Just gonna make a change to Surrey. Hello world, hi, Abhi Surrey. All right, that sounds good. So let's see. Next thing I want to do is that I actually want to be able to specify sending an actual HTML page, not just like this huge HTML string. So instead of just specifying the string in res.write, I'm going to use this other default library in Node called FS. And here, what I'll do is I'll also create a separate place where all my index.html and other assets can lie. And that's going to be in a public folder. And I'm going to specify a name of a file, index.html. Okay, so in here, I want to say hello from index.html. All right, cool. So instead of doing the res.write like this, what I'm going to do is that I'm going to call fs filesystem.readFile. I'm going to pass in dir name plus public / index.html. This returns a callback function or calls a callback function with an error and data if it's successful. So in here, what I want to do is if there is not an error, I want to say res.write data, and yeah. So one thing I should note that this is actually wrong, but let's just see if it works. And the reason why it's wrong and why we're getting an error here is because, once again, this is going back to our notion of callbacks. So the way that this would be executed is that we set the write head response, this call is initiated, then we end the response, and then wait. Later on, whenever fs.readFile is done calling, res.write data will finally be called, but we've already ended our response object, so yeah, that gets a little bit weird. We can simply solve this by just saying, putting all this res end stuff in the middle of our if statement. So now we have hello from index.html. Okay, so let's say that on our index.html page, we also want to include like a script. So let's say that it's going to be at public/test.js. Okay. And in here, I just want to call or create a file called test.js. Okay. So I think I just need to refresh NodeBOM because there are new files added into the system. And in test.js, just for good measure, let's just put in an alert. All right. So now whenever I go into my page, and let me just pull up the console here, I'm going to get an unexpected token here. All right. And let's see. The reason why I'm getting this token is because right now, whenever a request is sent to the page, it's sent to our server, what's happening is that the server is just going to send straight off index.html. Now, whenever this page is loaded, and whenever you look at the source for this page, you'll see that there's the script tag that's requiring public/test.js. This file is actually loaded after the HTML of this page is loaded. So whenever I go ahead and actually access public test.js, it's going to return back to me index.html because that's all that I specify my web server should be able to do. Whenever it receives any type of request, even if it's a request for not index.html, it's just going to be sending back index.html. So in order to actually rectify this, what we need to do is that we need to somehow read from what the request actually is. And the way that we do that is by doing accessing the URL of the request via rec.url. So just to make it clear with regards to what's actually being requested, I'm just going to console.log rec.url so you can see what's happening. Just pay attention down here in the terminal. So whenever I do a request to localhost 3000, it's going to load up the initial HTML of the page, and then whenever that HTML is loaded, Chrome is going to read up that HTML, see that there's a script tag that's going to be accessing this test.js script. It's going to initiate a request to the server to get that information. However, it's going to error out because Chrome is expecting a JavaScript file in return, but it's getting an HTML file that's actually index.html. So you'll see here that there are actually 3 requests that were made. One was to slash, and that's just implicitly implied whenever I just do localhost 3000. There's an implicit slash there. The other was to public test.js, which is the page that Chrome loads once it gets the HTML from the server, and that HTML actually requires test.js. And then the last one is just something that Chrome tries to load up on its own called favicon.ico. Which is just this little image here at the top in your little browser bar. Okay, so now that it's clear that we actually need to figure out some way to handle requests to different parts of our website and serve the appropriate pages, let's edit our fs.read file function a little bit. Okay. So what I'm going to do is that I'm going to initialize this variable called pathname. And off the bat, it's just going to be equal to public/index.html. But if we find that it is something that contains the string public, as it did in test.js, what we'll want to do is that we'll want to edit this path name. So if rec.url.index of public is greater than -1, i.e. it exists somewhere in the string, then we're just going to say path name is equal to dir name plus public, well, this string would already contain public, so we could just say rec.url. Okay, and then in here, we're going to edit this function to just say path name, because our path name already includes the dir name. And then in here, we can't be assured that our content is going to be HTML every single time. So what we're going to do is that we are going to just specify the specific file type. We're just going to say var file type is equal to pathname.split.pop, which is just going to get us the last part of this string here. So we're just going to say if file type is equal to .js, we're just going to set it equal to JavaScript, else if file type is equal to, say, CSS. And I think those are the only things that we're going to handle right now. We're just going to default over to HTML if it isn't any of those. So here in the content type, we're just going to put whatever the file type is. Okay. And then also, let's just handle whatever happens when there actually is an error. So here I want to say res.writehead, and then we're just going to throw a 404 error indicating something's not found. And we're just gonna say, sorry, file not found slash another error. All right. Yeah, I think we should be all set there. And now we finally get our alert from our JavaScript file saying hello there. If instead I decide to say like, let me try and access like that file. It says sorry not found slash another error because this file does not exist. File system threw an error whenever that happened. Okay, let me get rid of that annoying little alert. Okay, cool. So now you're wondering, where does all the socket stuff come in? Well, bear with me here. So in order for us to actually use sockets in our current web server, and we're just going to store this in our variable here called server, what we need to do is that we need to import the library that handles socket connections for us. And that library is called socket.io. So here I'm going to do npm install --save socket.io. Wait for that to set up. In the meantime, we're just going to start making our import statement. So I'm just going to say var io is equal to require socket.io. Socket.io actually requires us to pass in an instance of an HTTP server. So I'm just going to say io is equal to io server. Oh, and then also in here, let's just restart our server. And then lastly, once I have io instantiated, as I've done with this io server call, I'm going to say io.onConnection function socket. And we're just going to console.log the socket ID. Okay, so what this piece of code does is that it looks for any connections to the current WebSocket that exists on the server. Once there is a connection, that connection is represented by a socket object that's given to us by the socket.io library. So this callback function is passed in a single argument. We're going to be naming it socket in this case. And then whenever someone connects, we're just going to output their individual ID. Now, whenever I try and access my web page again, you'll see that nothing is printed out, and for a very good reason. So our socket.io connection does certainly exist on our server. However, our client, i.e. this web browser, doesn't know how to actually access that socket.io instance. So what we need to do instead is that we need to actually import the client-side version of socket.io so that we can connect to the server-side version of socket.io. And the way that we do that, there are like a couple ways that you could actually do it. One way is that you can go to the socket.io website and then download socket.io and put it into your public HTML directory. But I'm going to be a little bit lazy and just grab the publicly accessible link. Okay, so I'm just going to grab, yeah, that looks good. And in here, before my script source public test.js, I'm just going to say use that. And in here, once again, nothing has changed, and that's for a very good reason, because I actually haven't instantiated the socket connection itself. Importing the library is not enough. So in test.js, what I'm going to do is that I'm just going to say var socket is equal to io. And now this should actually instantiate the socket connection, because I am actually instantiating the socket client version on the client itself once it loads up this page. And you'll see here that our socket ID is actually printed out, and you'll see if you have Ajax debugging enabled in your Chrome console that there was a connection that was made. Okay, so that's the beginning part of actual sockets. So now let's get into the nitty-gritty part, which is involving actually sending messages from the client to the server. So first we need to specify some way for the client to actually input messages to send to the server. So what we're going to do is that we're just going to import jQuery so we have a little bit of an easier time actually interacting with our current HTML page. So I'm just going to grab the jQuery CDN. Let's go with the minified version. Grab that. So in here, I'm going to, all right, cool. And just for the sake of readability, I'm actually not going to continue coding in test.js. I'm just going to like keep on coding in this little script tag here. Okay. Let's move that back a bit. Okay. So here, let's just put back our socket.io code. Additionally, on our HTML page, let's set up a form with an ID of message form, with an input with ID message input, and then finally a submit button. Just call it like send or something. So in here, what I'm going to do is just to get set up really quickly and test if everything's working. I'm just going to set up a really quick listener on our form, and whenever it's submitted, I'm just going to be console logging whatever's in the actual input itself. Okay, so what I'll do is hashtag message form dot submit. Hold on, yeah, dot submit function. And in here, I'm just going to grab the value from our message input. And let's store that in a variable called message. And we're just going to console.log message. And to make sure that we aren't reloading the page, let's just do return false at the end. I could have equivalently done e and then e.prevent default, but like return false is just like easier to do, less characters to type. Okay, so whenever I refresh the page, I'm just going to type something in here, click send, and you'll see that pop up out here, not refreshing the page. Sounds good. So let's actually send this message somehow to our server. So the way that we do that is through something called emitting an event. We covered this briefly, I believe, at the end of, what was it? I want to say lecture 3. What emitting an event does, at least for sockets, is that it allows you to send a message. Well, it's not just like the text message that we put in here, but you can think of it as sort of like an object. So this object has like sort of, you know, or like the actual message, and this is just going to be like incoming chat message. And then there's actual data associated with that message, which is like, hi, my name is Abby. And so each of these events is given an identifier, and that would be indicated by this string, so that this string is sort of like the single source of truth for whatever is actually coming into the server or coming into the client. The way that we communicate over sockets is through something called emitting events. So here I'm going to emit an event. I'm going to call that event chat message from the client. And as the name would imply, that's just going to be sending along an actual chat message from this client. So here, instead of just console logging our message, I'm going to do socket, which is our current socket connection, dot emit. Let's just call it chat message. And we're going to be passing along the value message. All right, so now whenever I just refresh here, put something here. Oh, let me just clear out this so it isn't as confusing. All right, yeah, and I click send. Nothing's happening because I got rid of my console.log. Nothing's happening on the server. Now, why is nothing happening on the server? Well, the reason nothing is happening on the server is because we haven't told the server how to handle this new event called chat message. So in server.js, what I'm going to do is that in this io.on specification here, I'm just going to quickly say, okay, socket.on, and our event was called chat message, so on chat message, the function, let's just call whatever it's accepting as data, and let's just go ahead and console.log data. Okay, so now whenever I refresh the page, click send, you'll see here that my message is actually output. And I can even have multiple people connect here right now, actually. If I can make sure that my windows arranged correctly. Hey, Bob. Woo. We, and so on. I can even, oops, sorry about that. I can even sort of associate individual messages with people. And the way that I do that is very simple. I should say, way I can demonstrate that is really simple. Socket.io already does that for us. So in here, instead of just console.logging data, I can console.log the data and what the person's socket.id actually is. So I'm just going to say socket ID socket.id, comma, or sorry, plus, comma, message, plus data. Right. So now whenever I send a message here, you see a socket.id and then my message, and then here you can see a socket.id and then the message, and you know, as I keep on sending messages, you'll see that's actually associated with an individual client. So we're halfway there. So now as individual clients, we're able to send messages to the server. But now we want to be aware of whenever other clients send messages to that server as well, and we want to be able to get those messages. So how do we somehow actually figure out how to send messages to all people who are connected to our WebSocket? Because if this is like a chat room application, we want to be really extra and notify everyone whenever something comes across or whenever we post a message. Well, the way that we can emit messages to all of the people who are connected to a given socket from the server is to use not socket.emit, but io.emit. So io.emit, io, recall, just contains our actual socket.io instance. io.emit will send out a message to every single person who is connected. So in here, I'm going to store this as a string. So let's say, let's just call this str because I'm very lazy right now. And I'm going to io.emit. Let's call this, I don't want to call it chat message because that can be a little bit confusing. How about, let's server message, yeah. Or how about like message? Okay, and we're going to be passing along the string. All right, so in here, whenever I send something, nothing is going to happen. The reason for that is that once again, we haven't handled this message event. So the client is technically receiving an event. However, it doesn't know what to do once it gets that event itself. So in here, what we need to do is that we need to specify how the client should handle whenever it sees an event called message being sent from our server. So on the client, I'm going to do socket.on, very similar syntax to the server, message, function, data. Oh, I know my style is horrible, but please bear with me. And here I'm just going to simply console.log whatever that data is. So now, whenever I refresh the clients and I type something in, hi, you'll see here that this is console.logged. Not only is this console.logged on the person who sent the message, it's also console.logged on any other clients who are connected. So if I type in hello here from the other client, you'll see that this client as well receives that message. And I can just keep on typing things. Note that it isn't limited to just 2 people. You can have multiple people who are involved in this little chat. And so on and so on. Okay, so we're nearly there with our actual chat server. So now I want to introduce the concept of a user, because having a socket.id as your identifier can be a little bit daunting to look at, because it's just like this weird random string that no one's able to actually figure out. So one constraint I have is that I just want to be sure that no 2 users have the same username. So what I'm going to do is that whenever the client initially connects to our server, we want to prompt them for their actual username. Note that this isn't actually associating anyone with a given username, but this is just like some way of identifying people. So now what I can do is on the client, I will just say, hold on, let me pull up the code here so I'm not just floundering about. Just a second. Okay, so on the client, once the document is ready, I'm going to ask each client to pick out a username. So I'm just going to create this function called askUsername. You'll see why I actually have a function for this later on. And it's going to accept a string. Within this function, I'm just going to get the potential username, and that's via prompt. Okay, and then I'm just going to socket.emit. Let's call this new user. And we're going to pass along potential username. Okay, and let me make the actual call to ask username. Just a second here. Okay, yeah. So now we can just say ask username, pick a username. Okay, good. So now whenever I refresh it, let me just cancel out all the other things. Oh, and then also let's just console.log our potential username for good measure. Okay, so now whenever I refresh the page, I'll be prompted for a username. I'll just type in that, and you'll see that that's console.logged. But once again, since I'm emitting a new event to our server and the server has no way of handling that, we need to actually handle it. So here on the server, I'm going to say socket.on new user, and this is going to be accepting data. Let's create this array of users. All right, and then in here, what I'll do is I'll just say data or users.push data. Okay, so right now, and then I'm just gonna constant.log users. Okay, so right now I'm not checking for uniqueness in any way, shape, or form. I'm just going to be saying, okay, let's allow multiple people to be on the server with the same names. Refresh the page. You'll see that like Bobby can be put in multiple times into this thing. So here, I want to say that if, let me see what the check is again. Hold on, sorry, I always get this wrong every single time I do this. But I can just say that, So if users dot includes, I think it's includes data, what we want to do is that we want to somehow indicate to our client that they need to ask for a username again. So I'm going to be emitting an event to the client asking the client to request the user for another username. So what I'll do here is I'll do socket.emit, ask new username. And I don't need to pass along anything with that. So here on the client, what I need to do is that if I receive an event called ask new username, I need to reprompt our client for a new username, and I can do that conveniently through our ask username function. And I'll just say that like your username is taken, choose another one. Oh. Okay. So now let me just type in a new username. Let's call that Bobby. Oh wait, actually, hold on. I will need to push the new username into our users array. Okay, let's refresh that. All right, so Bobby. Good, so this person is Bobby. Actually, let me just redo this and console.log our users array so you all can see what's happening. All right, so let's refresh everything again. All right, so here, say Bobby. So you see that there's a new Bobby here. Now, if I refresh this and try to pick Bobby again, it won't let me. It's going to reprompt me. I can try Bobby again. Oh, I misspelled. But here I could say Bobby and Bobby again, and it will keep on prompting me. There we go. Now, we want some way to associate a socket ID with a given username. Now, there are a couple ways that we could do this. One is that we could say, like, forget about like storing anything on the server. We could just say that, like, oh, once the client has its username actually accepted by the server, then we could just say, all right, I'm going to be storing that username in some variable here, like test, and do whatever I want with it. However, this also leaves the opportunity for individual clients to specify what that variable test should be should they have like sufficient JavaScript knowledge. However, the one thing that they can't edit is the given socket.id that they have, because that totally depends on what order they actually manage to connect to the server in. Of course, there are probably some ways around it, but whatever, we're not really considering that right now. Anyway, so we need to figure out that once we receive a message from a given socket.id, is that actually, well, we need to like grab the username and then edit our given string here to be saying that like, okay, this is the actual username that sent it, not just the socket.id that sent it. So here, in addition to pushing along the given data, which is just the equivalent of the username, we need to also pass along the socket.id. So here I'm going to say id is equal to socket.id, and then let's just call this username, is equal to data. Okay. So now you'll see, now you'll see that whenever I refresh the page and put in Bobby, now I have an association between an ID and a username. However, once I type in Bobby again here, I can actually input Bobby again, because in here my includes check is not valid anymore, since we're now storing an array of objects. We're not just storing an array of individual string values. So I just need to make my check a little bit more rigorous. So I'm going to comment this part out here. And instead, what I will do is I'll just say how about this? I'm going to map over the users, which means just basically do like a for loop. I can spell function correctly. And you can look up the map syntax if you want to later on. It's pretty simple to look at. If i.id is equal to socket.id, then we know that there is a user with the given socket.id who has connected to the server already. So then what we can do is that we can say, or I don't think an ID check would be okay in this case. How about this? And we can actually keep our old code if that's the case. Or, sorry. What I'm going to be doing is that I'm going to be creating this array of like just users. This isn't the greatest way to do it. It's probably the simplest thing I can think of right now. And in here, I'm just going to be returning i.username. And in here, if just users includes data, we're going to ask for a username. Otherwise, we're just going to push it in to our users array. So what this is doing is that it's iterating through the current array of users. So it will go through ID this and ID that. And it's going to be inserting into this new variable some at the array index, just the given username. So just to console.log what just users looks like, just users, refresh the page, Bobby. Okay, so you see that just users was initially just empty. Now whenever I refresh here and I type in Bobby, you'll see that just users now includes Bobby here, and our actual array of users just includes that individual ID there. So let's just like say Joe or something. And if I refresh here and I say like George, you'll see that our just users array is always growing and stuff like that as we add new people. Okay, good. So now that we have an association between socket IDs and usernames, we want to edit what we send back on our chat message, or what we emit to everyone with our chat messages. So instead of just emitting along the message with a socket.id, instead what we're going to do is that we're going to be emitting out a message object back to our client. So here, what I'm going to do is that I'm going to, let's get rid of this code here. So I'm going to be saying, okay, let's look for a username that is going to be matching my given socket ID, because recall that whenever a client just sends a message to the server, I only have access to the socket ID right now. Okay, so if I'm going to be mapping over my users again, function I. So if I.id is equal to the current socket ID, then I'm just going to set username is equal to I.username. Okay, all right. So now I'm going to be creating a message object. And this message object is just going to contain the message. And that's going to be, data. And the user, that's going to be username. And lastly, we're just going to be emitting, what is it, server message thing? No, we're just going to call it message, sorry. We're going to be emitting in a message back to our client. And that will be message object here. So now whenever I go to my clients, refresh the page, Bobby, let me also add another person here, Joe. I type in a message, send. You'll see that now I am sending back a message object that has a message and a given user associated with it. Now from Joe's side, if I send another message, you'll see that that message object is also associated with Joe. So we have the basics of real-time chat built into this application here. Hold on just a second. All right, I'm about an hour in. 2 gigabytes of, oh boy, this is gonna be fun to upload. All right, so last part of this lecture is just prettifying this interface so that it's actually usable to interact with, yeah, not just like in the console itself. So here, let's just get started with some minor aesthetic changes. So within index.html, we're going to make a couple changes. So think that everything is good here. Yeah. Let us actually make this a valid HTML document. And then down here, make this look slightly more readable. In our head, let's just put in a title, sockets, and, oh, sorry, not slash scripts, slash title. Okay. Let's close out the head. In here, start the body. Everything else needs to be indented a bit because this is the body. And slash body. And up here, let's get rid of that. Let's have an unordered list called messages. And this will eventually contain li elements. All right, and this form is fine. And we have our script requires here. Only thing that we're going to change is that instead of just console.logging our message, why don't we actually append it to our messages div? We're going to create a new list element. We're going to set the text on that equal to message or let's call this data.user plus data.message. And then we're just going to do some fancy jQuery stuff with fading in the message itself. Because if we're using jQuery, we might as well take advantage of it. Anyway, so now, Bobby, oh, right, that's a nice username. Let me connect another client. All right, so now whenever I type something in, you'll see that it appends very nicely. Ooh. Oh, one minor thing is that once we get that message, let's just set message input empty. Okay. There. All right. Refresh. All right. That's marginally more usable. Okay. Let's prettify this a bit because this isn't too pretty to look at. So to do that, I'm going to be creating an index.css file. Oh, we also aren't using that, so let's just get rid of that. Anyway, index.css, and here, we're just going to be doing some very simple styling. Box. Okay. That's just to make sure that our entire web page is actually taking up the full window, because by default it actually like pads it a little bit. Not sure why, but regardless. So here I'm going to be editing the body selector, and I'm just going to say that our default font is going to be Helvetica if we have it on a system. Otherwise, it's going to default back down to Arial. Next, I'm going to say that our form element has a background color of white. Padding of 3 pixels, meaning that it's going to be have like a sort of like area of space around it of at least 3 pixels. Position fixed, meaning that it is fixed to a certain position on the page, and we're going to be specifying that it is 0 pixels from the bottom, and we'll say that its width is going to be taking up 100% of the page. Next, we're going to be styling specifically the form input field. And in here, what we'll say is that there is no border on this field because if you look at default, there is like this slight border. So border 0. Padding is equal to 10 pixels. Once again, enlarging that a little bit. Put a little shadow on it just for styling and because we want to look a little bit modern. So this adds like a shadow of 1 pixel and then a blur of 10 pixels, and that color of the blur needs to be 666, which corresponds to like a dark gray. Width is going to be 90% of the page, and then margin right, let's just call it like 0.5%, like a very small margin on the right. Now, you might be wondering where is this other 10% going? That's going to our submit button. So we're going to say form button. And in here, it's going to say that the color of that button. Oh, I should mention that color indicates text color. Yeah, it's not the same thing as like a background color. Width is equal to, well, I already put like a margin here, so it's not quite 10%. Let's just put like 9%. Background is this color, which corresponds to a rough greenish. Box shadow is just going to be same as here. Okay, no border, and then we're just going to be putting some padding around it, the same amount that we did for the other one. We're going to be stylizing our message div here, and we're going to say that it shouldn't actually have the bullet points, which I'm going to do with list style type of none, margin 0. Padding 0, because whenever they're list elements by default, they have like a little bit of padding to the left. We want to get rid of that. And, sorry, this needs to be messages. So then messages li, which is all the list elements under message, say that we're going to give them very specific padding values of 5px and 10px. I believe this corresponds to top and bottom 5 pixels, left and right 10 pixels, but I can be wrong on that. And just for a little fancy effect, we're just going to say every odd list element, we're going to say its background is going to be EEE, which corresponds to a light gray. Now from our index.html page, we need to actually specify to include this style.css file, sorry, index.css file. The way that we do that is through the standard import for style sheets. Yeah, okay. Now, let's see, let me make sure that we've handled it on the server, and we have. Okay, good. I was just getting rid of these dots here because actually this should be text/css. Yeah, I was getting rid of the dots here because whenever we split, that will actually remove all the dots. All right, let's see if this works. Get rid of that, refresh the page. You see that it's starting to work. All right, Bobby, there we go. So now you'll see that our web page is a little bit fancier now. Oh, not too fancy. Anyway, so you'll see that our input box is now transformed into something that's 90% of the page. Our submit button is now this huge green thing here. Whenever I type something, well, let me open it up on another person as well. Doe. Here, whenever I type something in, hello there, see Doe, hello there, and then on Bobby's side, I can say, hi. Hold on just a second. Oh, well, I thought that it was supposed to be, I thought that it was supposed to be like just the nth odd thing would actually apply, but for some reason it doesn't seem like it is. ULID messages, index.css. Messages. Okay. Refresh. Random username. Hello. That's much better. Hi. Woo. All right. Cool. So it looks like that I have 7-ish minutes left in lecture. Yeah, I think I'm gonna call it quits there. I was thinking about figuring out how to make sure that you can deploy this on Heroku. However, that may be a little bit complicated, especially if you haven't created a Heroku application before. So I am not going to be getting into that. Regardless, there are several guides out there on how to launch Heroku instances, and I may record something about that if enough people are interested. Regardless, there will actually be a lecture on how to deploy applications later on in the semester. Anyway, that's it. I hope you all have a fun parade. I will certainly be joining it as well. And yeah, see you all next time.